Okay, so number 5 says, if the gasoline in a full 20-gallon tank weighs 116 pounds, what is the density of the gasoline in grams per milliliter? Okay, so this question is simply just asking us to find the density. So if we recall what density is, which is rho, which is the Greek letter for density, is mass over volume. So here we're given a volume and we're given a mass. So all we have to do is divide these two numbers to get a density. But this question is specifically asking for our density to be in grams per milliliters. So that means we have to change our units of our mass and density to the right units. So you could pick either volume or mass first. I'm just going to pick my mass first just because it's on top. And I'm going to start off with 116 pounds. So with these 116 pounds, I want to turn them into grams. So I have to, again, Google how many grams in a pound, right? Because it's not given to us. It turns out that there in 1 pound, there's 453.5 grams in 1 pound. Okay? And by doing this operation, I get that I have 52,606 grams. Okay? That's how many grams I have. 3 sig figs, so approximately 52,600 grams, right? If we're keeping the sig figs consistent. So now I'm taking my volume, which is 20 gallons, and I want to turn that into milliliters. So I am first going to find out how many liters in a gallon, because I'm converting my gallons to liters first. Because that's usually the most common conversion that you guys are given. It's going to be 1 gallon per 3, and there's 3.78 liters per 1 gallon. Okay, so gallons cancel when I do this operation. So now from the liter point, I need to go to milliliters. So now this just becomes a simple SI conversion. So I know that in 1 liter, there's 1,000 milliliters because the milliliter is smaller than the liter. How many times? By 1,000. So that means that I have to have 1,000 milliliters per 1 liter. So if I do this operation, I am going to get an answer that's very big, which is 75,700 milliliters. So now that I have my components ready, I have my grams and I have my milliliters, I'm simply just going to divide the two because density is grams or is mass per volume. So that means that all I have to do here is divide. So if I divide 52,606 and 75700, I get a density of 0.6949. But in this case, I have to report 3 sig figs, so it's going to be 0.695, and that's in grams per milliliter, the units. So my density is 0.695 grams per milliliter, and that has to do with the reason why I reported 3 sig figs is because I start with 3 sig figs here, and I also start with 3 sig figs here. So since I'm dividing, the amount of sig figs just stays the same as 3. And that's my final answer, okay? So if we go on to number 6, it says dry sand has a density of 1.5 gram per centimeter cubed. A child sandbox measuring 4 feet by 5 feet is filled with sand to a depth of 6 inches. What is the mass of the sand in kilograms? Okay, so we're given the density of this sand, and we're given the measurements to a child sandbox. And we're asked to find the mass that's present in this sandbox. So, let's say we know that density is mass per volume, right? If we're given an external volume, let's say in the problem, they give us the volume. Let's say that they had already given us the volume instead of the dimensions. So let's say we had the volume of the sandbox. If we had the volume of the sandbox and the density, if we multiply the density times the volume, turns out that we get the mass. Okay? So the way that I want you to approach this problem is we first have to find the volume of this sandbox because we have the density. All we're missing is a volume to find the mass, because at the end of the day, we want to know the mass of the sand in kilograms. So then we asked ourselves, how can we find the volume of this sandbox? Well, it turns out that we have the measurements, and it's a box. So we know that a box, if we draw a box, the dimensions of the box that make up this box are a length, a width, and a depth or a height. So we have the length and the width and the depth. So if we multiply these things, if we multiply that these three components, we find the volume. So 4 feet times 5 feet times 6 inches. Well, we run into a problem here, because if we multiply this across, we're going to get stuff in units of feet squared inches, which is not really helpful. So that means we have to convert one of the units into the same unit. And it seems here converting the inches is the simplest because all my other units are in feet. So that's a simple conversion. There's 12 inches per 1 foot, right? And that just happens to be 0.5 of a foot, half a foot, right? So I could replace this 6 inches in by feet. So that's 0.5 feet, okay? So then when I multiply these three things now, I'm going to be left with the volume because my units are in feet cubed. Anything to the third power in length is going to give you a volume. Just remember that. So 4.0 times 5.0 times 0.5 give me 10 feet cubed. So it turns out that my sandbox has a volume of 10 feet cubed. Now that we have the volume and we have the density, we can multiply the two to find the mass.